again, welcome to the last part of the 3 trainings, Advanced 2 training. And as always, the important information that this training will be recorded and you will get access after the training. So that shouldn't be a problem. So a short introduction to my person. My name is Kuemmel. I'm project manager and senior software consultant at MicroStream. I'm a software developer for 13 years now, around, doing a lot of, so at the moment I'm doing a lot of projects with MicroStream for 2 bigger companies. One is the Allianz insurance company, and one is the Fraport, the Frankfurt German airport. We do a lot of projects on that, especially for microservices with MicroStream. And yeah, that's quite challenging, I would say. So if you have any questions regarding that projects, feel free to ask. Okay, this is the timetable for today. So as always, we start at 5 o'clock and we do till 9 o'clock with a short break. Somewhere, not exactly at 6:30, but somewhere around that. So I think that's okay. Oh, what's going on? Okay, let's go through the topics for today. So or just wait, there is one quick question. Okay, regarding the certificates, that's a good question. We still working on that. So we prepared all, or we collected all the email addresses from the trainings before and also from today. And no worries, you will get it. So we are working on that. So I would say it's on the way. You will get an email and yeah, this will contains the information where you can get your certificate. Okay, so yeah, let's go through the topics. As always, I want to start with a smaller or medium-sized warm-up project. We will see. The special thing for today is that so I will do it directly with you together. So if you want, you can code along with me. I think that saves us a little time, so we don't. So it's always, I don't know. I decided to do it directly like this, so it saves us a little bit time, and we have enough time for your question at the end. So that warm-up project contains a lazy loading and also backup configuration and stuff like that. Especially these are especially topics from the last advanced session, but there are also basic topics in it so that everyone can follow and code along. That shouldn't be a real problem. One of the first core topics of today, I would say, is configuration advanced. I think we already talked about the channels of MicroStream, but it's always a question how to change the channels. Is it possible to change it or not? And I think I prepared a small project. We will just have a short look on that project. And since version 8, there is a channel migration feature within EclipseStore, and that enables you to change the amount of channels within your project. So there is kind of like a migration. And we will have a short look at this. Next step is housekeeping. This is also quite interesting because, as I always explain, EclipseStore just adds or appends data at the end of the storage itself, and sometimes it's necessary to handle that in a special way. And I will give you an idea how to do that. That's the part of housekeeping. Then next, exception handling. Some of you asked in the last advanced session how to handle transactions and rollbacks, and that's why I added this topic again on the advanced 2 session. And I prepared a project for you, and I would say that's a little bit a best practice project and how to handle that. And I think that's would be quite interesting to see that. Then this is kind of like a filler, I would say. It's the MicroStream REST interface. There is one built-in REST interface within EclipseStore, and I will skip that topic at the beginning and do that at the end if we have enough time, because there are some more interesting topic at the end. And this is the concurrency handling. I would say that's the most important topic for today, because EclipseStore forces you to do a more precisely concurrency handling, and this is how to do it. I prepared a lot of examples for you, and we will do it step by step, and I will show you all the important stuff regarding concurrency handling. It's not only for EclipseStore. I think it's a Java all over topic, but yeah, this will be quite interesting. And last but not least, oh, not last. So this is the last one. We talked about customizing. There are 3 projects also available in my GitHub account regarding type handlers and special legacy type handling. This is a quite deep stuff within MicroStream. I personally never used it before, but in some cases it could be quite helpful to know how to handle this, and therefore I brought 3 projects for you that you have smaller examples to see how it basically works. And now, last but not least, I want to talk about some clustering stuff, how we do data replication within EclipseStore and MicroStream, and we go a little bit through the cluster solution of MicroStream, and I will explain you how it works and why it works like this and stuff like that. Okay, really interesting, I would say. I hope so. And yeah, I would say let's jump in. You should start with concurrency. Yeah, could be interesting, but I want to start. Maybe I changed the order a little bit. So, but anyway, let's start with the warm-up project exercise. This is to bring everyone to a level that we can do it together. And maybe I will start with the concurrency before all the other topics. Would be interesting. But yeah, we will see. Question answers. Yeah, before our sessions, these sessions are recorded. You will get access to the recordings afterwards. Ask as much questions as you can. I leave enough space for your questions. Just sharing the URLs with you. Let me just do that directly. So this is my GitHub account. So where you can find a lot of more examples. Then there is another GitHub account, which is also, of course, quite interesting for you. This is the MicroStream GitHub. This one. And of course, the MicroStream documentation. And it's the same on, EclipseStore. You will find the same content on EclipseStore too. These are the links I want to share with you. Oh, that's great. Thank you, Marcus. So as you can read, there is EclipseStore version 1. That's really great. So maybe change from 27. Okay, good so far. So do we have some question directly at the beginning? No. Okay, just to summarize, For those of you who are the first time within the training, what is MicroStream basically, or what is EclipseStore basically? It's a Java framework. It contains or consists of a from scratch invented object graph serialization that enables you to update the serialized data or the binary data at the end partially. That's I think that's the special thing in it, and this is why MicroStream or EclipseStore becomes more and more kind of like a database. As I said, it's an in-memory database, so that means your data stays in the RAM, and with some lazy mechanisms, we are able to define some parts of the storage itself, which should stay on the hard disk, and that's it. There is no data mapping or mapping all over mapping annotations anymore. So you can use your Java beans and objects directly as they are, and this is your as I said, your Java object graph becomes the database graph. I would say there is no data mapping in between necessary anymore. And at the end, you will get you just change the data in the RAM, and MicroStream takes care to keep RAM and storage synchronized. I would say that's an all-over explanation about EclipseStore and MicroStream. Okay, let's move on. Let's move on to the exercise. This is where you can find the exercise project. Let me just share the link directly. Here we are. So this is the warm-up project. This is what you can do. You don't have to. There are several branches, or there are two branches in this project. One is the starter branch, where we can start to do the coding stuff. And as I said, we do this directly together with small explanations from my side. And you can code along if you want. And there is a second branch, which is called, I guess, implementation done. And all the stuff is ready to use. And at the end, or if you want to try it out, so just use the implementation done branch to start the project itself. The project itself consists of it's a Micronaut application, and most of the projects we're doing here are Micronaut applications because it's easy to use and it enables us to create some REST interfaces to test the application, and therefore it makes sense on my side. I'm used to use Micronaut a lot, and that's easier for me to handle that. Okay, you can start on the main branch, as I said, and it starts with some classes which are needed when we work with EclipseStore. The first one is the DB class, and you have to initialize the storage manager at the DB class. And then we have some one controller class which is called book controller, and these classes are the two you have to complete. The special thing is you have to use the builder pattern to initialize the storage manager. As always, I would say this is the preferred way to initialize. And these are the backups. These are the configurations we want to have. So at the first, we want to have the storage target, or the store target should be the data folder. The backup target should be named backup. And this is one thing from the Advanced 1 training. We want to set the lazy clearance to 10 minutes. So that means after 10 minutes, when an object is untouched, it will be cleared by the MicroStream framework. So this is the setup we want to have. And I would say let's start. Okay, so I also prepared that a little bit. So this is the bookstore. So can you see my screen? And are the letters big enough so you can read it without any issues? Let me just open the code. I think it should be okay. The size of the code. So let me just double check. This is the main branch. Everything is okay. Okay, so hopefully you can read it. So as I said, let's start on the DB class. And as you can see, it's empty. And we're doing things a little bit different. When you remember to last week, we used the static method to initialize the DB. And let's do it a little bit more micronaut way. So how to use this classes at the end. So there are some people that want to join. Okay. So what we always need the initialization of this embedded storage manager. And so just a second. Okay, here we are. So let's create an instance of a storage manager. Let's say public. So let's do it in a normal way. Embedded storage manager, and let's call it storage manager. So I forgot to say, if you need any time to check out the project, and let's do the configuration stuff to run the project at the end. So if you want to start it, you have to do some adjustments within your IDE. Maybe you have to enable the annotation processing, but let's do this at the end. So we start at the DB class and add some two instances which are important for MicroStream. The first one is the embedded storage manager. It's kind of like the database management system, and then we need public. Let's do it final also. Call it root, or let me just call it root, and we call it root at the end, equals new root. So just for explanation, the data root is the upper object of the graph itself. So I would say it's the entry point of the graph, and this class is already here. So let's open it. Here you can see it is called root, and we will fill this class later on. So let's move back. So in the example before, we used the static block. We would not do this in that way. So let's create a normal constructor here in that class and take care of the initialization. And let's start with the builder pattern. So let's say, okay, the storage manager equals, and we use the embedded storage configuration dot builder. It's always the same. And then let's start to set the configuration. Let's set the channel count. And I guess we said that channel count should be 2. That's enough for us. Next, let's set the storage directory. So, and as I said, it should be data. We want to have a backup directory for the mirroring. So that means to create a mirror, and the data will be mirrored on every store. We call it backup. And that's it, I guess. So 3 configurations, and based on that, we create the embedded storage foundation. Here we are. Based on the foundation, we create a storage manager. And at this point, we add the instance of root to the storage manager. So that is because the storage manager needs the entry point of the graph, its root, and then we say start. And that's it. So that's all we need to do to initialize the embedded storage configuration. But we said, okay, we need a lazy clearance every 10 seconds. And we have to do this before the initialization of the storage manager. So, and based on that, we could say, so lazy reference manager dot set, and let's create a new lazy reference manager dot new, and let me just skip the line. So line break. Let's say lazy checker, lazy dot checker, this one, with a duration dot of minutes. Let's say 10 in that case, dot 2 milliseconds. And I think dot start. So that is all we need. This is how it looks like to create or to change the default behavior of 30 minutes lazy clearance to 10 minutes of lazy clearance after an object stays untouched within the storage. That's it. Any questions so far? That's all we need within the DB class. Let's do some special Micronaut stuff. So we want to initialize that class directly at application context. So that means whenever the Micronaut application starts, we initialize the storage itself. And therefore, we need the context. And what else we need is some get and set methods, or in just a second, we use the final keyword also on the storage manager. And then we create some get and set methods, or only the get, of course, because it's final. And that's it. So I think that's enough to use the DB class in later other classes. Okay. So as I said, some questions directly for now? No. Okay, let's move on. Let's jump directly to the root class itself. Just open my version of the root. Yeah, we want to store books and authors. And as I said, we want to do this with some lazy mechanisms, and therefore let's go to the root. And I will do this I would say in a way that in my experience is the best, or which works all the time. There might be better solutions, but it works great most of the time. So we create a hash map or a map, and we said let's do a string and a lazy list, which contains a lazy list of books. So that's it. And let's say new hash map. Okay. maybe it makes more sense to change that, because we have to create another one, another collection. And in this collection, we use the author object. So, but in a different way, in that case, we use the author directly. So that means we create, these are the authors. And in some parts, it could make sense to change that, because for sure we have more books than authors, and maybe it makes sense to do it in a different way. But yeah, you can do it on your own. That's totally okay. So let's create some get and set methods, and that's it. Authors and get books. There is one question: how is the binding between the lazy reference manager and the storage manager is done? There is no real binding in between. That's a good question. So, I think that's a really good question. Maybe I have to forward this to Florian. So, sorry, I can't. I'm not able to answer this, but I will take the question with me. So that's interesting. I also want to know. So I take the question with me, and yeah, would be interesting to know. Maybe he counts the lazy objects within the RAM or stuff like that. Not sure exactly, but yeah, could be interesting to know that. Maybe you could find the answer also within the documentation, but give me the chance to have a look at the break. So maybe that could help at the end. Okay, let's move on. So the root object is done. So let's have a short look to the book itself. Yeah, it's already in place. The book and the author objects are already there. So there is one field which is a transient one. Yeah, this you always need the transient when you don't want to store the alias here, for example. Then you can do it in a transient way. This field will not be stored at the end. And now we can move on to the book controller itself. Here we are. So there are some already created methods here. We have the create method, the create single, and some helper methods to search stuff. What we need at first is we need to inject the DB class. So let's add an inject DB and let's call it DB. We will need this later on. So this is a Micronaut related thing or Spring. You would already knew this. So we inject the DB class, and then we could start to add the books. So, and first of all, we need to create some books. And I already created a mockup utils class, which loads the mockup data from JSON files down here. It's an author and a books JSON file, and it creates objects for us. And then we could store the objects. And the first thing we want to do it, because we used hash maps, then we need to iterate through all created books. And let's do it like that. So let's say for each, and let's say B for book. This is what we need. Let's iterate, and then we use the code. So that means db.root.getBooks. This is the, now I have to change this. So let's do it like this. .getroot.getBooks. And then we say compute if ascend. So that means, do this if the project or if the object is not already there. So we need the key. We use the ISBN as the key within the map. And in that specific case, we use the first 2 or 3 letters. It's a little bit up to you. And therefore we say substring, and let's say the first 3 letters of the ISBN. Maybe we could also do the first 4 letters of the ISBN. This is kind of like an index. So let me just move this down a little bit. So B get ISBN substring 4. So we use the first 4 letters of the ISBN as an index within the map. And on the value part, we say we do this the lazy way. So we say lazy dot reference, and there's a new array list. So, and after that we say dot get, give me that array list, and then we add the book at the end. So just to give you an idea how this works. So if this is the check if the substring here is already there as a key, and if not, it creates a new array list, and it adds the element to the hash map, and it creates an empty array list. And this method returns the array list, and therefore I use the get method to extract the lazy element, and the get gives me the array list, and then it enables me to add the book to this array list. And if this substring is already in place of the hash map, I will get the already existing array list. So that's how it basically works. Okay, I have to store that, and I will do this the same way. So let's do db.root get authors. I do this the same way. So, and I would say let's just copy the code for that. That makes it a little bit easier. It's the same way, but in that specific case, I add the ID of the author and the email address of the author and the last name as it could be comma separated, or as an index to search within the elements, and I add the author directly as the key. Okay, we have to store this, of course, and let's say db.get storage manager dot store all. And let's do this way. All created. Store all. Okay, I have to use this one. Already there. Get root dot get books. Okay. here we are. That's it. So a little bit more, I would say, yeah, extended example of creating stuff within MicroStream. Yeah, but yeah, I think it's really straightforward to do that. Okay, to save a little bit time, I would like to copy paste the stuff and just go through. There is most of the time it works the same, and so it is also on the create single side. I just have to move that a little bit in this way. So let me just change this. Get root, get book. And we need the storage manager again. And we only need this one. Okay, that's it. Oh, there is another arrow here. So now we have that. It's kind of like the same. Nothing special on that. And now the next steps, I think, are a little bit more interesting, especially to find or to search for it. We want to do it so we look for starts with 1. That's okay, that's easy. So let me just copy paste this, and here we are. Let's change this to get the root. That's it. Book. And we need to import the collectors to list. So as always, we use the Streams API to find data within MicroStream. And that's what we have done here. So we go to the books through the root. We go through the entry sets and stream through the keys. And therefore, I want to filter and say, okay, give me all the keys starts with 1. And to collect all the data together, or to map it to one list of books, I use the flat map function to create one list of books, and at the end I say collectors.toList. Because there are for sure multiple keys which starts with 1, I would say. That's it. And the last one is how to update, or how to update multiple books. And also based on that, I create, so let me just copy paste this. That's a longer part, or longer code part. Let's talk about this again. So let me just copy paste from the storage manager. Okay, here's this one. And we need the reloader. Okay, we want to talk about this a little bit later again. So this is the part where the transaction stuff comes into play, and in my opinion, it's not that important that we talk about all the stuff. Let's just have a look at, in that specific case, we create a lazy store. That means that so we will be able to register some elements on that lazy store object that enables us to call a commit at the end. So that means we register every changed object directly on that store, and at the end we say, okay, store, please commit this object, or commit that, and with that call, all the objects are going to the binary files, so at once. So that's kind of like a transaction way. And if something went wrong within the try block, So we have a catch block here and we do some reloading stuff. But yeah, as I promised, I come to that later again when we want to talk about transactions and rollback and stuff like that. Okay, that's it for now. It's, as I said, it's a little bit more extended way to a more extended data graph, I would say, or data model, especially with lazy loading. And I think the lazy part, it's important to know, especially, let me just to be that get method. So whenever you want to change something, you have to load. And yeah, that enables you to get the object out of the lazy wrapper, and then you will be able to add something at the end. Okay, so let's try this. Hopefully that will work. So let me just double check books. I inject the DB class. There is something within the root. Configuration should be in place. Okay, give it a try. So it will be interesting. Let's move on to the application class, and especially for those of you who want to check that, when you open this in your IDE, you have to enable the annotation processing of Maven. Let me just check. I'm not able to. Yeah, I have to do it this way. Let's go to the preferences, and you will find this on Maven. And there is one point which is called annotation processing, and it should be on experimental or automatically configured. That's up to you. Both will work at the end, and that's important. What I forget to mention is that we need, of course, we need the MicroStream dependencies within our POM XML. Here we are, and in that specific case, I used the 800. That's okay. The newest one is the 811, I guess. This should be the newest version or latest version of MicroStream. So let me just update the Maven project. Okay, let's start. Let's see if this is working as expected. Okay, basically it looks good. So the Micronaut application starts up, and as we configured it, also the embedded storage manager is initialized directly on Micronaut startup. That's how it should work basically. And let's call the local host books, I guess. Books. Let me just move books. It's called, so there is not found on 8080. Something went wrong, I guess. So /books 8080. There is. I see. Okay. So we have to call the create method first. So there is no. So let's do it this way. So as you can see, book successfully created. That's good. There are no errors in that. And when we now have a look to the project itself, let me just refresh that. Yeah, we should see the data and backup folder here up there. So this is the data itself, and the backup is the mirror. We have 2 channels as configured. So that's working good. And now try to use the ISBN starts with 1. Let's do this. Instead of create, we use the ISBN starts with 1, and it should return the right data. Yeah, great. That's how it should work. So I think it's not really necessary to do all the other stuff or all the other interfaces. I think it's enough to see, okay, it works, it stores the data. One check, what we can do is let's close the application and start the application again and see that the data is already in place. And that, yeah, you see data is there. We directly call the ISBN starts with 1, and this is the data at the end. So we have one question: why is in the DB class everything public? Oh, you're right. So you are totally right. It makes more sense to have that private. I think it's because my sloppy programming way. So most of the time I'm a project manager, not a programmer itself. So that's why. Can you please share the GitHub link in the discussion window panel? Thanks. Okay, just a second. Then I can share this again. That's the link to this specific application, the bookstore warm-up training. Okay, now we are. Any questions so far, especially for those of you who joined the first time to the training and you have seen MicroStream the first time, how it works and how is the code working and stuff like that. And yeah, if there are any questions, feel free to answer. Okay, so yeah, and as promised, maybe some of you have to leave a little bit earlier, so therefore I will start with the exception handling and with the transaction stuff. And I prepared a project for you. Let's save this. It's also available on GitHub. Give me just a second to share this with you. Exception handling should be the right one. Let me just double check the branches we have. Rollback impulse. So let's start with the master branch. Okay. So you can find the project itself on my GitHub account. Here we are. That is the exception handling project. Okay, that's the project. By the way, there are 2 further questions. One is, what is the database connection type? SQL, NoSQL, etc. It's just the file system. I think that's important to know. In that specific case, or in that warm-up project, we use the file system as the storage itself. It's, yeah, normally you would send the data to some other databases like, yeah, as you write to a SQL database like Postgre or Oracle or stuff like that, and Oracle does the storing part for you. It stores the data there to any hard disk or persistent volume or whatever. With MicroStream, we do this directly within your project, so we don't have to send the data through the whole world or through the internet to a database. We store it directly to the hard disk. And there are some possibilities to use a file system like AWS S3, for example. But yeah, it would be a further example. In that specific case, we use the file system directly. So we stored it directly to the database or to the hard disk. So okay, and the second question was more on change management. What you can challenge taking teams from database management system. Yeah, I think that's in fact that's a challenging task. But more on that, I would move this a little bit at the end when we talk about the clustering stuff and so on. And this will enable you to have some persons in place that takes care about administration and stuff like that. But on the other hand, there is no database team more needed, especially when you use MicroStream or EclipseStore as a framework, then it's part of your application. Of course, there are tasks to do, but most of the stuff is doing within your application or is done within your application. Okay, hope that helps a little bit. We want to talk about exception handling, and there are two parts which, in my opinion, are important to know. And I realized that in that project, and therefore I created a DB class. And this is a DB class we created before. Oh no, this is not the right one. So that's the old one. Here we are. So okay, that is a quite easy DB class. It's a little bit, the initialization of MicroStream is a little bit different. So in that specific case, I used an XML file to do all the configuration. But we have to talk about one special situation, which is important to know. So let's imagine we store something and something goes wrong. So let's imagine we call the db.store, or we use the storage manager to store something. And then after that, something goes wrong, or we are not able to store it anymore, then we have a problem. So because we already changed the object graph itself, so that means nobody would mention that something has changed in the background, and but yeah, you can work alone. You will get exceptions, of course, in the backend or inside the logs. You will see the exceptions, but on the database or on the application side, you will not notice that there is something wrong, because so yeah, the question is what could go wrong, basically. So because we store the data directly to the hard disk, and but in some rare cases it could be that maybe a persistent volume is not claimed the right way, or something went wrong. Maybe your file system doesn't have enough space to store MicroStream or stuff like that. There are some rare stuff that could go wrong, but you have to cover this situation, because when you work along with your application and again, you will not notice, because you change the RAM all the time. All the other users will see, okay, everything is working great. The data looks like it should look, because you changed it already, but you're not persisted it directly to the hard disk. And that's a big problem, because at the moment you restart the application, you will see that there is no data anymore, especially all the data which are entered after that error, so is gone. And this is a big issue. So, and we have to take care about that. And I've done this in the second branch here. We just switch to best practice done. So this is the way I've done this within the application. So what I created is the normal builder pattern as always. this is the storage manager. And the special thing here is that I wrapped the store methods within my own methods again. So you see there is one for store all, and one for store for the iterable. And you see I wrap this within a try catch. And whenever you call the store at the end and something goes wrong, it says, okay, on storage failure, it calls this method. And this method stops the application directly. So there is the context, the application context of the Micronaut application, which is injected here. So there is one, this is where the application context is injected. So I need that context, and based on that context, I could say, okay, stop the application, and there is something wrong. And that's important. Some of you might say, okay, is there any way to rescue the database or to restart the application? I would say no. If there is something which goes wrong directly on store, then there must be a big issue in the background. So there is no data, no hard disk in the background, or as I said, the persisted volume is not claimed or stuff like that. And that means you have to stop the application directly. And this is what happens here. So I created this in a special way, especially for Micronaut. So there is one class which is called application hooks. And whenever I call context.stop, it stops the application itself. And I inject the DB class here, and then I say db.getStorageManager shutdown. And that's quite important to do that to prevent that error I described before. I'm pretty sure there are many ways to do that, but this is what you should do all the time. There is another interesting point, especially on the shutdown method. Whenever you stop your application, you should call the shutdown. You should shut down the storage manager all the time. It is not part of the documentation for the moment, but in my experience, it makes sense to do that in case that, let's say, someone stores something right at the moment you stop the container, for example, and it makes sense to integrate one REST endpoint just for using it to stop the storage manager and shut down the database itself, and then you will be able to quit the container. Most of the time, there's not an issue to just clear or just shut down the container. This is working great most of the time, but just to ensure this is working as expected, shut down the storage manager will do it the safe way. And it's the same on that. So whenever you stop the application itself, we call the shutdown method before, and then everything works fine. This is what this is, in my opinion, one of the most important things you have to do when something goes wrong on the storage manager store method. You should stop your application. There is one question. Shutdown is like the flush method. Yeah, it is like that. Yeah. So it ensures that all the already existing stores are written down to the hard disk, and it ensures a proper shutdown of the storage manager. So there is another question. Hello, can we optimize the program code data structure? Of course you can. So you mean afterwards, or afterwards? So after we start the program the first time, you will be able to update the structure at any time. So when we have gender or email or stuff like that, you can add it, you can rename it. That's possible at any time. But you have to follow some rules, I would say. This is part of the Advanced 1 training. there is a come on, it's a how is it? A legacy type mapping. So this is named, and it's kind of like a versioning. Whenever you change something, a new version of that object is created within the storage. So first we have version author version 1, and when we add something, we have an author version 2. And whenever we touch an old author object within the storage, it will be converted to the newer version. And this works really great in most of the times, I would say. Sometimes it could be a little bit more difficult, especially when you change something within the structure which cannot be handled automatically. So then you have to do it with some, for example, when we want to change, let's say the ID, which is a string at the moment, let's say we want to change the ID to an integer field, for example. This is what never can be done automatically. So, and I would say it's the same on any database on the market. So you have to do some migration stuff in the backend. And in that specific case, I would recommend to create a second ID attribute, for example, and then start up the storage and do the migration stuff in the background, and that's it. I think I would recommend to do this in this way. But there is a huge section of exactly that topic. Just have a look to the documentation. That works really great. But yes, to answer that question, you will be able to update the data structure after. That's also an interesting question. Are there mechanisms in the EclipseStore like listen notify in the PostgreSQL to notify the app about some changes have occurred in the data? That's interesting. That's an interesting question, because it is what everyone needs to have, right? So this is what I always explain when we talk about caching and a PostgreSQL database, which provides the data to a lot of different applications, which doesn't know each other. So that means many different application accesses to one central database, and I think that's the same in that specific case. There is only one application, and this application has the data directly in memory. So this is why your memory becomes the single source of truth, I would say. The data within your memory is the state of the data. There is no way to change the data on the hard disk, and therefore it's not necessary to notify the application that something has changed in the background. The only one who can change the data is the application itself. And this is the point where the application or MicroStream forces you to create kind of like a data provider for data. So when you want to serve the data to many different applications within your architecture, you have to create one central data provider, and it provides the data via REST or some other technologies to all the different applications, and then that solves your problem. And yeah, I think that's interesting to talk about, but it's always the same. I could remember 10 years ago, people explained it to you that always create kind of like a data provider, especially when you want to serve the data to many different applications. And at the end, everyone accesses the same database from a lot of different applications. But yeah, it's totally up to you. But to answer that question, in that specific case with MicroStream, it's not able and not necessary, because it's an in-memory database. Your RAM is the single source of truth. There is no notification needed. One question: do we need to reboot the operating system each time we run in the shutdown option process? I would say no. There is it is possible to shut down and start up the storage manager within the same process. That's basically possible. But in that specific case, when an error occurs or something like that, of course you should restart your container or that. But it's not necessary to restart. So you could start the database. You could restart the database at any time. What happened to the cache the data stored in the operating system memory each time we run the shutdown option process? So as it is, as we said, it's an in-memory database, and when you change something in the RAM, in the next step you have to call store, and the store stores the data directly to your memory, or sorry, to your hard disk. And so that means it works like a normal database. With the only one different is that the data stays all the time in memory, most of the time, except the lazy elements. But when you call shutdown, basically everything should be fine, or the last store should be completed, and then the database shuts down. So I think this is how it basically works. Okay, so let's come back to the exception handling. So as I explained, this is the first step. So you have to take care about the huge error. And now that brings me to the next step, to do exception handling, kind of like a transaction. And therefore I move on to the next branch. There you are, here, team, switch to a rollback implementation done. We already checked that. We already checked that in the advanced 1 training, but I improved that specific example a little bit. And as you can see here, I added one data access object class, especially for books. And inside this example, I created some methods, which is called add books, clear books, and yeah, give me a list of all books, update multi-books, and so on. And this is how it basically works. You see, this is a DAO class, I would say, data access object. And in my controller class, I only call these methods of that data access object. Add books, give me a list of all books, and stuff like that. And then it makes it easier to handle something. And that brings me to the transaction stuff. So let's say there is one method which is called update multi-books. And this is what I've explained before. So there are two possibilities to create a storer, which is kind of like a transaction. So there are two different. One is the lazy and one is the eager storer. So you can see that here. And the differences between the lazy and the eager storer is that whenever you so the lazy store is the default behavior, by the way. So that means data is stored always the lazy way. That means that only the object is stored, which you creates the call. So that means when we say in that specific case, let's say, okay, this is a book, for example. When we say b dot, or let's say db, let me just a second to create a db dot get storage manager dot store. When we call the store method and we set b as an example, like this, only the book itself will be stored. But the book consists of an additional field. Let me just show you that. The book, there is one field which is the author field here. You see that? And its author is a sub entity of book. And let's imagine you changed something within the author. Maybe you changed the last name or the first name or whatever else. And you call this line of code to store the book. Only the book itself will be stored, not the author object. And that is how the lazy storer works. And the idea behind the lazy storer is to prevent huge files to store, because in that specific case, we only have a book and an author, right? So there's not a big tree, I would say. But sometimes it could be possible that you have customers with a company and orders and products and stuff like that. And then it makes sense to have that functionality to only store the upper object, not with all your sub objects. So this is, by the way, as I said, this is the default way to store objects. But it is possible to create an eager storer. And with that eager storer, you will be able to store the whole graph from the upper object beginning to the lowest one in the chain. So this is the differences between the lazy and the eager storer. But on this specific case, we use this lazy storer to get kind of like a transaction behavior. And based on that, we say, okay, let's stream through all the books we have and set the price to 50. And then we have to register. I think that's the name of that method. It's a little bit unlucky, I would say. Maybe we will change that in the future, because it leads you to misunderstanding the way it works. So in that specific case, we say, okay, lazy storer, register the book B for storing it later. And if all the changes are made, so we call the commit method at the end. This is how transaction basically works on the code side, on the MicroStream side. And now let's imagine something goes wrong. So let's say we change the first 20 books, for example, and then something happened. Whatever could happen. So then we use the try-catch mechanism to catch the error and use the reloader. So there is since version 7 or 8, not really sure, we implemented the reloader, and that reloader enables you to revert some stuff. This is kind of like a rollback, I would say, and it reverts, and it works the same way like lazy and eager. So there is one reload flat. It only reloads the data from the hard disk, and there is a flat mechanism that reloads only the book itself. And this, in this specific case, it's totally enough to call that, because the set price is a direct field of book. So therefore we call reload flat and B, and we are totally fine. And there are some points where it makes sense to have a reload deep down here, for example, and then we use the reloader new, and here we call reload deep. And with that reload deep, all the sub objects will also be reverted at the end. And this is how it basically works. So that means we use the create lazy or eager storer for transaction behavior, and we use the reloader to reload data if something goes wrong. So any questions so far? Let me just drink a little bit. So and I think that also answers the question, how does the store method determine which book or author to update? I think that's really straightforward. You call the store method directly on the object itself. So db.store, and you have to add the object which has changed. That's how it works. Okay, I see. There is one method which is, in my opinion, it's a quite dangerous method. It is called db.storemanager.storeRoot. This one. So this is a really special method, and some of our users think, okay, that's great. Let's do it this way, that we just changing some parts of the data, and after a few minutes, we call store root every, let's say, every 4 minutes or every 10 minutes. Ooh, that might work on some smaller projects for sure. But when your data grows more and more, as I explained it before, data is always attached or appended to the database. That means, let's say we have one customer, then we say, okay, store the customer once and do it the same store on the same customer again. And every time we call store, this specific customer will be appended to the end of the storage. And that leads to an increasing storage again and again. And that's and there is one housekeeping process that deletes all the duplicated entries within the storage. And when you call this, you have to know that the whole root object, that means the whole storage, will be appended to the storage on the hard disk. And of course, that leads to a huge amount of appended data at the end, which is not a problem. The housekeeping can do this for you and cleans that up after a while. That's why I'm said, okay, for some smaller project that might work, but you should be careful with that method, I would say. You should use it this way. I explained, so db.store b, and that's it. The method is here, and sometimes it makes sense to have that, but most of the time you won't need that anymore. So and
hi Christian, here, David here.
Yeah.
I don't know if I understood it quite correctly. So I meant your information was good about root storing, but I don't think I understood the lazy store method, because this is the method I meant. So when I understand the code, yeah, you for each you put the storing object in the lazy store, and at the end you, if I understand it correctly, you commit everything. So and at this point it's written to the disk.
Yeah, that's right.
So so what I don't understand is, how does the lazy store method know to which collection the book belongs? Is this some automatic mechanism? So because we have we have our root, and in our root we have these two lists of books and authors. And but the store method takes care of deciding to which collection to add, or how does it work?
I think that's the point is that you don't have to know where the book what collection the book belongs. So that's not really important to know that. In that specific case, we changed a primary attribute of the book itself. So we said set price, and each object within the RAM consists of an object ID and kind of like and a type ID. And this is how MicroStream knows where to store that. So within the storage, the binary parts also consists of a type ID and an object ID. And this is how it basically works. The object itself belongs to the collection only on the Java side. So, but on the RAM side and also on the storage side, it's not important to know where the object is. So it's just
So it's just for updating, and when there's also when there's already a reference to the object.
Yeah, that's right.
Yeah. Okay.
That's right. And this is also an interesting question, because it's always important, and in my experience, the biggest issue we mostly have, people always call us and say, okay, I tried to store something, but it doesn't work, and what is the problem? It's always important to know you have to store the element which has changed. So in that specific case, of course, we change the book because price is a primary attribute of the book itself. But what about adding a book? So when we say we have a collection and we want to create a new book at the end, we are used to store the book, especially with PostgreSQL and Hibernate and so on. When we create a new book object, we always store the book itself. But this is not the case with MicroStream. With MicroStream, we have to store the collection, because the really thing which has changed at the end is the collection itself, because you added a new book to the collection. So, and that's why whenever we create an object and we want to store that object, we have to store the collection where the object belongs, because this collection has changed. And that's the point.
Yeah, thank you. It's quite interesting. Helps to understand it better.
Yeah. Okay. Okay. So, so let me just so many questions and try to find. A lot of questions. So how to store the book author to update the chat? Okay, I think I answered most of the questions. There is one question: is there a backup option for the project app? It is, and we created it within our warm-up project. We created a backup file, and it's kind of like a mirror, but there is also a full backup functionality behind the scenes. And you just have to check the documentation. There is, one line of code which creates a full backup of your storage, and you will be able to store that full backup wherever you want. So on an AWS S3 bucket or stuff like that. It's totally up to you. It's also possible to have your hard disk as a storage. And to create your backup on an AWS S3 bucket, for example. That's also, and there is one example project within my GitHub repository, and just check it out. So everything is in place, I'd say. Okay, but let's come back to that specific case, transactions. Some of you might say, okay, understand that, and it works, but what about if this process needs longer than 5 minutes, for example? It's just an example. So let's say to iterate through all the books and to change that, it needs, or let's say it needs 2 minutes. Then you would say, okay, what happened if after 1 minute something went wrong and all the other people are still working on because all concurrent users are working on one graph, right? So this is how MicroStream basically works. So this is also the part where we want to why we want to talk about concurrency. And this is not a part of transaction. It's the part concurrency, and we will talk about that later. But that's, in fact, it's an issue, and you should take care about that. So it's, most of the time it's not important, because to have a transaction that runs for 2 minutes it's not that often, but it could be the case. Okay, so this is all I want to talk about: transactions and rollbacks and exception handling. And I think are the most important things, is in my opinion, to ensure that whenever something happened on the store method, that's important, then you have to shut down the application. Then something weird is going on and you have to fix it, and most of the time it's a bug, or the disk space is not enough or something like that. The problem with your transaction code, even if you create a store once you call store without commit, the object is not in the tree and another thread will read it. Yes. Yeah. Let's do that within the concurrency. But yeah, the object is in the tree. Yeah. Okay, let's move on. So no questions so far regarding the exception handling. I think that's straightforward. And this is just a suggestion from my side, right? So you can do it in 1,000 different ways in a more, yeah, you know, it's just Java. Use the Java, yeah, use Java as you want. So it's just an idea from my side. Okay, let's close this and let's move on to the concurrency topic. Yeah, that's okay. So we start our break at 45. So we have enough time to go through the presentation. So I prepared a presentation for you. Let me just open that. Concurrency handling. A huge topic and yeah, a dangerous topic, I would say. Okay, first, when we talk about concurrency, we have to specify what layers of concurrency we have. So that's interesting to think about. Okay, what issues could happen and what layers of concurrency we have, and do we need to take care about concurrency on MySQL, for example, in comparison to EclipseStore? We have to check that. What is the differences between that two technologies? And it could be MySQL or PostgreSQL or Oracle. That's all the same. So why is it different to EclipseStore? Is EclipseStore responsible to take care about concurrencies? That's also an interesting question. Can EclipseStore help you to handle concurrencies? Let's clarify that. And then I prepared a project for you, possible steps to solve concurrent access. And these are, at summary, there are 4 different branches, step by step, that shows you how to handle concurrency within your application. And at this point, that brings me directly to the point where I can share the project directly with you. So concurrency, here it is. So directly to you, this is the link to the project. But we need that project later on. Okay, so as I said, let's talk about possible steps. Let's talk about immutability, proper object models, proper architecture, locking stuff, or concurrent collections. Let's talk about this. Okay, this is, so as I promised, we have to clarify the different layers of concurrency. And this, I would say this is the first one. I would call it the tag layer. So it is tag related. So for example, iterating through a list of items while someone else's deletes item in it. So I think that's the most straightforward situation, and you will get a concurrent modification exception. That means you have to prevent concurrent access on your Java side. So the question is, why was this tag side not necessary on your SQL database or on your on your Hibernate implementation? Most of the time you don't care about that specific tech related stuff, but with MicroStream or EclipseStore it becomes more important. That's the first layer, and in my opinion an important layer we have to talk about. The next layer is, I would call it the business related layer, and especially in that case row or item concurrency. What happens within one line of your data? So one row or one item. And one really important or really famous example is that there is a customer with an ID 20 and last name is Doe and first name is John. And the first user changes the last name, let's say at 8:50 or something like that, and changes the last name Doe to Baker. And there is another user too, which changes the first name from John to Mike, barely at the same time, I would say. And user 1 stores the customer, and user 2 stores the customer. And due to the fact, there's a thing, we always write the whole item, and that's the problem. And the changes of user 1 will be gone, and that's the problem. So at the end, we will have a data set or a row, a customer which looks like this. It's 20, Doe, and Mike, because user 1 changes Doe to Baker, but user 2 gets the same row, but again with Doe in it as last name. And as I said, due to the fact that we always change the whole line again, the change to Baker will be overwritten by the change of the second user. This is what we do most of the time. We use the locking mechanism of the database itself, right? So we use a pessimistic lock or optimistic lock solution within Hibernate when we use relational databases, right? So this is a scenario which can be handled by the database itself, and I would say this is the only scenario which can be handled by the database, because there is another layer of concurrency. I call it data consistency concurrency. It's just a word that I created, I would say, and it's also business related because and let's have a look at this. We are a car selling company, for example, and there is one rule: only one car should have 20% discount at a time or at a day. That's okay. And let's imagine user 1 calls a method which is called get discounted car. So and you will get a result. It's car 1. And there is another user which calls the same method right after the user 1, and it gets also car 1 as a result. And user 1 calls the set discount to car 2. So that means in the end, car 2 is discounted at that point. And we have the same on user 2. And the second user calls a different car. So in that specific case, car 3 is discounted. And both users try to remove the discount at the end from car 1, because both users are getting car 1 as the previous discounted car. So this is an exception, or this is an example where multiple rows are within the involved to that situation, and this is a situation which cannot be handled by the database anymore. So this is concurrency which is needed to handle by your business logic. And of course, you would say, okay, that's quite really clear. So I have to take care about myself, creating some transaction stuff within, or using a special word on that get discount car method, for example. So we could say, okay, let's create a method that changes, let's create a method that do the whole change at once. So let's say the method is called set discount to a new car, for example, and all the steps get discounted car, set discounted car, and remove the discount from a car happens in one method. And then we could do a synchronized or stuff like that. That will solve the problem, but it has to be solved by yourself. It's a business related topic. So and I would say it's the same on this side. Even if the database could handle that, it is a business related stuff. You have to take care about that. And I tell you the reason for that. I'm pretty sure you could use a locking mechanism or stuff like that, or you could use optimistic lock. But in the end, you have to do something in case of an error. So what happened if something goes wrong? So let's say we use optimistic lock, and you want to store it, and you get the message, oh, something went wrong. most of the time, I know, and in 90% of all cases, people say, okay, then clear the second store, and that's it. And it's bad luck for user 2. He has to do it again. And that's why you always have to add some business logic behind or at the end. And it's not enough to say, okay, I log the data. What happened in case of something goes wrong? And that's why I would say it's business related. You have to do something in that specific case. Okay, so we identified that 3 different layers of concurrency, and we have to take care about it. And with that knowledge, let's have a look just to why is concurrency a special thing within MicroStream, or why do we have to handle that in a specific special way? So when we have a look to a normal, it's just an example, MySQL, for example, or PostgreSQL relational database, we have the database itself, and most of the databases, I would barely say all of them are single-threaded on the database side. So there is one queue, and this queue stores the data directly to the hard disk. But whenever we access the database, you will always get copies of the object. So this is not, you will always get a copy, and this is one copy for session A, one copy for session B, and one copy for session C. And that's the reason why we don't need to handle concurrency with that, because every user has its own session and has its own object copy. That means there is no concurrency on level 1. As I said, level 1 is the tech level. No, this always is an object copy. I don't care about that. But on level 2 and 3, yes, you have to take care about concurrency in some ways. And I think it's the same on the client side. So if you have some client side stuff, Java, JavaScript or stuff like that, then you have to do also the same. No level 1 concurrency, but on level 2. And on the database side, it's single-threaded, no concurrency, of course. So let's move on to EclipseStore. How is it different to a normal database? It looks like this, that we have the client side. In that specific case, it could be a Vaadin application, for example, or it doesn't matter if this application is separated from the database itself. But in this specific case, or because MicroStream is an in-memory database framework, I would say, always the database is part of your application server. Most of the time it is. So, and it works really great. It in some situations it works better than to have a separated data provider. But this is the case here. We have some clients here. As I said, no concurrency on level 1, but on that level we have to take care about the tech concurrency issues, because we are working all on the same object model, all on the same object graph. And you remember that issue that we try to iterate through a list of objects, and someone deletes elements of that. And this could directly lead to an issue, especially on the technical side, you will get an exception. And therefore, that's important to know that there is something special on the EclipseStore database. And yeah, as I said, it's the same here. So it's the case that we have a storage server or a data provider, could be a Spring, Micronaut, Helidon project, whatever else. And we have some REST endpoints. And in that specific case, sure, we provide object copies. It's the same situation like on a PostgreSQL database. So that's the reason why we have no concurrency here on the app server side and also on the client side. But on level 2 and 3, it's the same like on a Postgre database. But on the storage server side, it's the same. Of course, we have some REST endpoints, and it's kind of like a different session, I would say. But at the end, all these endpoints are working on one object model. And you have to take care about concurrency on the technical side. So I think that's different. So that's different. It's only the technical side with brings us problems. Okay, I think that's important. So is EclipseStore responsible to take care about concurrency? Yes, in a way it is, because what happens after the store method is called? So EclipseStore uses the operating system standards file locking stuff to prevent simultaneous access to the storage files. That's what EclipseStore can do for you. But EclipseStore is not responsible for your business intelligence. And in my opinion, it is a little bit more complicated to do that. And it's a little bit of a trade-off, I would say, a trade-off between performance and complexity. And that means MicroStream serves you an insane amount of performance. And if you need that specific performance from a technology, you have to deal with the trade-offs. And the trade-offs are the complexity, but it's not really complex if you know how to solve that. And this is why we are here, and I want to share this with you. There are thousands of different URLs and different web pages or stuff like that to explain you how to handle concurrency, but all of them are quite confusing, and there are a few things you have to know. And that brings me to the possible steps to solve concurrency issues, and I will go with you together through the project and show you the different steps. But this will be the case after our break. There was one question regarding design pattern architectures for MicroStream, but I have to say there is no preferred design pattern. It's totally up to you. You could use any pattern you want. That is totally up to you. I would say MicroStream fits in most patterns. I would say that's totally up to you. Then just one thing, there is no database management system in the middle as a medium between the program code and database connection process. Yeah, that's exactly what it is. It's kind of like a native Java storage, I would say. So that's, I always described the situation in the past when I tried to use JSON, for example, as a storage. And just to serialize data to JSON and store the JSON file and use this as a database. Sometimes that would be a really great solution, but when the database grows more and more, this is no longer possible, because you have to store the JSON file every time at once, and that's a big issue, and that's why it is not working. And yeah. And this is why MicroStream is also that impressive or powerful, because we are able to change the binary part partially. That's what it is. So okay, so let's move on with our concurrency stuff. We stopped at the first step to solve concurrency issues, and just a second, just to double check we are ready to go. Yeah, okay. Possible steps. Let's start with step one. And step one, handling concurrencies. And the funny thing is, a lot of web pages suggest you to prevent concurrent access whenever you can, because shared resources are always leading to an I would say to a decreased performance. So that's fact. So that whenever you have concurrent access, it slows down the performance, and therefore they suggest to prevent concurrent access whenever you can. So in our situation, we are able to do that. So we are able to prevent concurrent access. And in step 1, I show you how. So that means prevent shared resources between threads, of course. Try to use immutable objects whenever you can. That's also important. And I will show you a solution how to bring objects or how to create immutable objects. This is one solution. The till Java 15, I guess, records are part of Java. So it's possible to use records instead of using normal Java classes. That is one way to create immutable objects. And of course, there is another way that keyword final creates an immutable field, I would say. Not an immutable object, but an immutable field. And of course, if all fields of an object are final, the object becomes immutable. But it's much easier to do that with a record at the end. So when you are able to use Java 15. The next step is try to really reduce the amount of concurrent access as much as possible. That's in some parts, this is possible. And I will give you a small example how to do that. And yeah, and of course, you have to change the data model for that. But this is not really a big issue because you are used to use a database like in tables, right? So that means when you have a database, you have one table for customers, one for orders, one for positions within the orders, and so on. Everything is divided in tables and lists and stuff like that. And that means you always have to operate on that list. All the concurrent users have to operate on that lists, for example. And this is different on the MicroStream side because now you are able to create hierarchical structure. That means the order is no longer organized within a list. The order is part of a customer, for example, and that makes things easier when it comes to concurrent access. And for single-threaded access by using synchronized, and in my opinion, I wrote if possible. In a lot of cases, it makes no sense to use synchronized because synchronized leads to a situation where the performance decreases that much that sometimes it makes no sense to have that. But it's a proper way to do that. In some situation, it makes sense to have synchronized. Let me just clarify that a little bit later. So, okay, so let's switch to my IDE to show you the step 1. So here we are. Okay, concurrency, and let me just double check which branch do we need. So team switch to step 1, immutable. Let's discard this. Okay. This branch is not a branch where the application can run. It's just an example branch that to start the application on that branch will not work. But let me just show you one thing before, just to give you an idea of what it means to have a concurrent issue. It's the first branch, and there is one controller class, the book controller, and there is one method. It iterates all the time through the list of books, and there is one method to delete a random book out of that list. And let's see what happened when we call these methods. So, the application class and start this. Okay. So I use the browser to call these methods. So let's call the books. You see, the application starts up, MicroStream starts up, and storage manager is initialized. Oops, and you see the database is empty. So let's create some books. Let's call the create method. And then you will see, okay, there are some books. And now let's iterate. You will see that in the console, you see now the loop is iterating again and again. And now let's try to delete one specific book, and you see that happens. It happens not always. In some parts, this will work. It's not that case. That it depends a little bit on how fast the operation is on the and to be honest, most of the time you will not get an exception like this, because most of the time that is working great. But especially when we iterate through the list again and again, that happens that fast, that this issue happens all the time. And now let's jump up to the exception itself. Here we have it. It's the concurrent modification exception, and this is the exception I talked about. It's a tech related exception, and we have to take care about that first. Okay, I just wanted to show you that. So let's move on to the next branch, to the immutable branch. And as I said, you will not be able to call that. And the first step I want to explain is the thing, try to change your object graph. So in that specific case, we have a list of authors there, right? So it's kind of like the structure of a database, of a relational database. We have one collection of authors and one of books. And let's say we have 20 concurrent users, and or even more, and they're working on that list of authors. It could happen that we have some issues. Some of the concurrent user iterates through the authors and searching for something, and others deleting values here. In some parts, it makes more sense to say, okay, we don't need this list anymore, so let's skip it, or let's remove it. And instead of having a list of authors there, it could make sense to do something like, oh, come on, what happened here? So now we are, yeah. So it could look like this. And when we have a look into the books, we have the authors this way. So that means sometimes it makes sense to change the data structure a little bit, and it solves one aspect of concurrency problems within that list. This is possible, basically. It's not possible always. It's not always possible, but in some cases that might help to prevent concurrent access, because each object within a book, maybe some persons only working within a book, and they change the author directly within the book. That leads to a concurrent situation within other books if other books have the same author. That's true, but we come to that later. Okay, that's the first point. We can solve something. Next point is the keyword finding. We already talked about that. And in some parts, at the beginning, I was a little bit confused how this could work. So let's say when we have a look to a book, for example. So we have an ISBN, we have a name, we have a release date, price, and author. And all that fields are private, are string. So let's talk about the ISBN. And is it possible to change the ISBN of a living book within our application? Can an ISBN change? No, that's not possible. So if whenever a book becomes or starts to live, then the ISBN is set, and no one is able to change the ISBN, because you had to delete the book instead of changing it. And therefore, it makes sense to say, okay, let's do this final. Because ISBN could never change. What about the name of the book? Is it possible to change the name of a book? No, it's not. So let's do it. Let's say it. Okay, let's do the name also fine. What about the release date of a book? Is it possible to change the release date after a book is created? No, I guess not. So because the date is somewhere something, and maybe it's someone creates a book with the wrong release date, then you should delete the created one and create a new one. So that's the solution for that. What about the price? Yeah, the price could change. So let's keep this for the moment and let's talk about the author. And in that specific case, we say, okay, also the author is not able to change. So because a book belongs to an author, that's what it is. And let's add a final at this position. So, and now at the moment we see this, we could make a decision. We could say, okay, our book is barely immutable. The whole object is immutable, except the price here. So why not to move the price in a different location? So let's say there is a specific, let's call it kind of pricing table or stuff like that, which is working with a reference, a primary key or stuff like that. And then you can remove the price here and put it into another collection, and then our book becomes totally immutable. And based on that, we will be able to, instead of having that, we will be able to create a record. And then a book could looks like, and I created the same example with an author, for example. So like this here, I created an R author, a record author. I created that R because the author is already there. So what happened here? Did I miss something? Let me just maybe update this. Maybe that solves the problem. Yes, here we are. Now it looks good. So a record here, it creates a immutable object at all. And this is a quite good solution, especially for prevent concurrent access on the item level, because there is no way to update an object anymore. You always have to create a new one. And this is a quite good solution to prevent concurrent access on the object layer, I would say. Another step in the right direction, to use final as a keyword, to use the record to create immutable objects, or final to create immutable fields. And yes, that's it basically. So I would say that's the first steps to a great architecture of your objects. Okay, let's move on. Next solution. Let me just jump back to the presentation, and I think I made a mistake here. So yeah, I mentioned it here. Oh, come on. Sorry for that. Yeah, let's move on to the next branch to talk about the next solution to switch to the synchronized stuff. Okay, so the architecture changed a little bit. So that means when we now go to the book controller, you have already seen that I created a data access class, which is called data access object book, and it's the same we already seen in the example. And the first step to use this, you could, instead of using, oh, give me just a second, where is the root object? So here we are. So the first thing we could do is we could use synchronized collections. So this is a way to do that. That enables us. So now we move a little bit from prevent concurrency within an object with immutable stuff and so on. So we could use what about how to handle errors on a synchronized list, for example. And this is one possibility to make your objects, or you make your collections synchronized to prevent that concurrent modification exception. This is one solution. But to be honest, it's not the best one, I would say, because it's synchronized every access, no matter if it's a read or a write, it's synchronized everything. And yeah, this will lead to an increased reduction of performance. But to be honest, for some low frequented collection, this is totally okay to have that in this way. The performance will be quite amazing anyway, because of MicroStream itself and because of the in-memory aspect. And I would recommend to do this on any low size or even medium size collection, to use this the synchronized way. This is one possibility to do that. So if you don't want to do that, there is another aspect which is explained also in the presentation, to reduce the amount of accesses to the collection. And you can do this within the data access object class, because whenever you add some books, you could say, okay, let's add synchronized to that method. Synchronize. So now we, come on, what's the problem? Synchronized. Okay. Okay, I see. So that leads to a lower frequent access, especially so let's say we could do synchronized on the store method, right? So that could also be possible. When we go to the DB class, we could say, why not to synchronize this one directly here? Why not to say, let's do the synchronized stuff here? This will be possible, but this will synchronize every store method, every store to MicroStream, and this is not what we want. So and to be more granular, so we could move this to the data access object class and use synchronize on different add books methods, or the clear books are synchronized, and so on. That makes sense to decrease the amount of accesses at the same time, because of using different methods to access it. That could make sense, but yeah, I would not recommend that at any time or every time. So there are some more possibilities to use. Any questions so far? So we're doing concurrency handling with Java methods. So it's just the pure Java language. Okay. So let's move on. Next branch. What is the next step? What next method or what step could we do to prevent concurrent access? And that leads me to my personal favorite, which is called the reentrant read-write lock. And just give me just a second. I want to show that. So let's keep the root object here. So the collection is a synchronized list, right? So we should be able to start the project and doing the same what we have done before. So let me just delete that. We no longer need that, and let me just start this, just to improve that there is no tag concurrency issue anymore. So up and running. Just check if there are some books. No, there aren't. So let's say create, and then we say iterate, and now we could try to delete some books. And you see, this is working great. So we are able to delete books, and everything is working as expected. That is what we want to have. Okay, next step, as promised. So as I already said, the reentrant read-write block, let's discard this, is one solution, which comes, it's a quite old technology. And for that, we created a class for you, which is called read-write locked. It's done by us. So Florian created that class, and it's just an helper class to create the mutex and to divide the read from the writes and so on. And this could be quite helpful to you. What does it mean to have that? Let me just show you the presentation here. What is the difference between the reentrant read-write lock and synchronize? So both technologies doing the same. They lock the access to something. Yeah? So that's the same. But the usage of synchronize is more rigid, I would say. It locks every operation. It doesn't matter if it's a read or a write, so it locks everything. So that means if we have 10 reads, then it will lock every read from the others, and that's a problem. That decreases the performance, and that differs in the reentrant read-write lock. Here we are able to separate the read from the writes, and we make the decision. Reads can go through no matter, can do it in parallel or stuff like that. And so the reentrant read-write lock gives us the possibility to do that. Next point is the synchronize is tied to the block structure of Java, right? So that means it's part of the method, it's part of the field itself, and the unlock will be released when you exit the Java, the code block. And this is also a point where the reentrant lock it's different, because it's up to you to release a lock. You can do it whenever you want. You can create a lock wherever you want, and it's totally up to you to decide when to release the lock. Next step is the reentrant lock has a fair mode. That means it's not the case on synchronize. Synchronize doesn't have an order to decide, okay, this one want to read and thread whatever else. It's not ordered. Instead of the reentrant lock means it's a fair mode with a first in, first out order. And yeah, it's not the case on synchronize. That's also interesting. So a reentrant lock allows a thread that is holding a lock to acquire it again. That it sometimes makes sense, especially to be more performant, I would say. And that's on the pro side. Okay, and there is an API to get methods about the locks, but let's check how it is solved within the project itself. So as I said, there is one read-write locked class we created for you, and these two interfaces belongs to the read-write lock, so we don't need that anymore. Let's close this. And I added the read-write lock as an extend to my data access object class. And now this is a quite powerful solution. So because I'm now able to create some blocks like this, so I'm able to decide, okay, this is a write block. So that means in that specific case, something happened which writes data to a collection, for example, and I can store the data. And I think I'm not sure. I'm not sure who asked that questions. What about what about if someone changed something in the background? This is a solution which helps a lot. We can say, okay, this is a write, and this should be locked against this write, and so on. You see the iterate itself, it's just a read, and that's okay. That's also only a read method, so we don't have to lock it against the iterate, for example. And this is a write again. And this is a quite powerful solution. I like it a lot. So, and we could do a check if this is also working like the solution before with the synchronized collection. So let's start up. So the data is still there. Let's check if this is working. So it's empty. Okay, it creates the data directly. So let's say create. here we are. Here are the books. Let's iterate. And now let's try to delete some books. And as you see, it works the same. It works quite good in the same way that the synchronize works. And I would say it's definitely more performant than the synchronized way. Okay, so next step. What else could we do next? Reentrant, read write log, my personal favorite, I would say, because it's quite good readable and a good solution. Of course, there are some more things you could do, and this would be step 3: usage of concurrent collections. And there are there are 2 different concurrent collections. There are some more, but I would say there are 2 most important ones. The first one, which is, I would say, the best one of the 2, is the concurrent hash map. It works really great, and it's also it's always recommended by other famous Java developers, I would say. Concurrent hash map, and there is another one which is called the copy on write array list. The difference between the 2, of course, it's quite obvious. The one is a list, it's an array list, and the other one is a hash map, and they are working different in the background. There is only one thing you have to know about this. You could use the copy on write array list whenever you just want to most of the time you read data. So the copy on write array list is quite slow when you want to write data in it. So whenever you want to change data within a copy on write array list, you should not use it. Most of the time, let's say 90% reading, 10% writing. So for that solution, copy on write array list is okay. For all the other solutions, I would choose the concurrent hash map. How they work internally, I think it's not a part of that training here, but I just want to mention these 2 hash maps, and I've done this in the project on the next branch. So let's move on to the next step. And this is also, yeah, nothing special and really straightforward. Let's check the root. Oh, okay. Okay. Yeah. Okay. This is the data root, and it consists of one books object. And let's jump into the books object. And you see, this is another way to create a data structure. One books object consists of 2 concurrent hash maps, and we have string books. We already seen a structure like this in the lazy way at the startup project, and I think it could be a solution also for you to have multiple indexes with one specific object. So, for example, if you have one huge collection with books and you need special indexes, and of course a list which is structured by authors and ISBNs and so on, that makes sense to have a structure like this. And in that specific case, I used the concurrent hash map, which is working really great also on when concurrency comes into play. Okay, so let me just jump back to the presentation and see if there is something at the end. Guess not. I think that's it for all. Okay, that's the topic. That's concurrency. Some of you might say, "Ooh, okay, really? That's all?" Yeah, it's not more than this, because it's just Java. You could do whatever you want, and with all that specific cases and tools, you could fix your concurrent issues. And whenever you can, I would recommend to use the reentrant read write log. I think that's a great solution. I like that much, and that prevents you from multiple accesses. Let me just Where is it? Oh, here we are. Yeah, this way. Just check it out. You already have the link to the project itself, and try it out. And I think that's a proper solution. Okay, any questions so far? Not so far. Okay, so let's move on. Next topic. Next one will be. Give me just a second. I have to. I have to check this. Okay, we do configuration advanced. That's the next topic I want to share. How to configure and how can we migrate the channels, and especially for that, I created a new project which is called channel migration. Let me share the link to the repository. Oh, where is it? Here it is. And to all of you, here we are. This is the project channel migration. It's just a really small. It's a really small project which consists of only one. This is the right one. Let's try it out. So there is, let me just double check the configuration. Here you can see we start at channel count 2. So there is, let me just refresh this just to ensure that there is no Okay, so let's start this. Just have to check. Okay, setup data. It's different than the other projects, but this will work. Oh, books are created. Let's check if they are in place. Oh, I have to use this one. What happens there? So, did I make a mistake? Book and then books.
/ books is missing.
Ah, thank you. Ah, okay. Ah, that's why. So / books. Yeah, now we see the data. And the question was always, okay, how can I migrate from one channel to, or from 2 channel to 4, and from 4 to 8, and so on. And therefore, we created a small helper method. So let me just we see that when we call the refresh, or when we refresh the project, you see this is the storage, and you see the channels here. This is always a question for those of you who have never heard of that channels. It's a possibility to access the data multi-threaded, and especially when you use a lot of lazy loading, it could help you to increase the performance because it enables you to access the data on the hard disk within multiple threads. So that means for each channel there is one thread who could read the data, but you have to choose the amount of channels, and most of the time we use something between 1 and 4 channels. I would say that's a number which works great. When it becomes to a greater number, 8 or 16 channels, for example, then the data are that segmented that it takes more time to load it or to read it. Yeah, but it is only, I would say it's most of the time you will need an increased amount of channels, especially when you use a lot of lazy loading, because the data stays in the RAM most of the time. You don't have to access to the storage or to the hard disk, and that's why it's not needed to have multiple channels. And therefore, but if you want to change it, there is one method which we have here. It's you create a second configuration. You say embedded configuration dot builder set channel count to, and you create the foundation, and then you have the target configuration, and then you use the storage converter here, and with the two different configurations, and that will do the trick. So that means let me just start this. And this will convert the channels to 4 channels. Just refresh it. Now you see we converted it to 4 channels, and this is working really great. Normally you had to create a second storage manager to copy. You have to copy the data and so on. That makes things a little bit easier, I think. Just a small topic of that training, but it's quite helpful to know there is a way to convert the channels. Okay, let's move on to the next step. What was it called? Housekeeping process. Yeah, I want to give you a short explanation about the housekeeping itself. The housekeeping consists of multiple different tasks which are done in the background by MicroStream, which are running in the background, and one of that is the housekeeping itself, or we call it housekeeping. That means whenever you add something or when you change something within the storage, it will be attached or appended, as I already explained. And we need a process that cleans up all the duplicated entries at the end. And this is what we call it. This is what we call housekeeping. There is another task which runs, which is called garbage collection, and it works quite similar to the garbage collection of Java itself. That means whenever you delete something within the storage, you need someone who removes it from the storage, and this is done by the MicroStream or EclipseStore garbage collection. And we have to define how often that housekeeping should run. And this is by default, it's we could have a look in the documentation to see that, but we are able to increase that. And the reason why we have to increase that sometimes, that's why I want to show this to you. So let's close that. We need the configuration project. Hopefully this is the right one. Let me just double check the branch housekeeping example. That makes sense. Okay, this is a small example project I created just to demonstrate why it is sometimes helpful to have that. When we have a look to the book controller here, we see that there is an in stream, and I'm doing stuff. I iterate through 10 times through the creating the mockup data. That means here within, I guess there are thousands of books within the JSON file. Not sure about. Let me just check that. There are, yeah, 1,000 amounts of books are inside the JSON file. And this happens that fast that appending the data creates a huge amount of storage, and we want to prevent this, and therefore there is a way, and we tried this with the default way. As you see, this is the MicroStream XML file where the instantiation of the storage manager is configured in that specific case. And you see there is a way to increase the housekeeping interval and the time budget. But I want to see what happened if we keep that way. What happened on the hard disk side? That is quite interesting. Let me just check foundation. So we need this storages anymore. Don't need this. Just delete that. Okay. And now we are good to go. So DB class application is needed. Run as Java application. Oh, one moment. I have to do maybe an update first, just to ensure that the object or the project is properly built properly. So team run as. Okay, so now when I now call that create method, we have to be fast enough. Let me just open this before show in System Explorer. Here we are. So the data folder should occur directly here. So the data folder should occur here, and now let's start it. So where is, oh, okay. So let's call localhost books/create. Now it's up and running. You see the data folder and you see the files within the folder itself, and you see what happened. And in that special case, the housekeeping is not fast enough to clean all the channel files. And when we wait for some more, the housekeeping will delete the files. And you see the file size is 8 megabytes. And after the 8 megabytes around, a new file will be created at the end. And as I said, when we wait a little bit longer, the housekeeping will decrease the amount of .dot files in that case. Maybe it's already done. So when we do refresh here, but I think we need to increase the housekeeping, and then you will see the difference. So let me just delete data folder. Here we are, and increase the housekeeping a little bit. And this is for those of you who when you want to add data in a high frequent way to MicroStream, you will need to adjust this a little bit just to prevent the increasing amount of files on your hard disk. Okay, let's start. So we are still there. Okay, let's call the create method. Application is running. Here is the data folder. Let's have a look. And now you see the amount of files stays the same, or barely the same, I would say. And this is why the housekeeping is working more often. It has more time to store the data. I think that's okay. It's just a small example of what you can do, and it's an advanced topic of that. But I think it's important to know that this is possible. You are able to increase the housekeeping. And yeah, there were projects in the past where we had to adjust that. The more, especially with an increasing amount of concurrent user, it could be the case that you have to increase the housekeeping interval and time budget to improve the storage a little bit. That could definitely help. Any questions so far? Let me just drink a little bit, or drink my coffee. Okay. So, did I share the project with you? The configuration project? There are some other helpful stuff inside. Maybe I want to share this. Makes sense, definitely. It is called configuration. not able to find it. So just a second, configuration. Here it is. There are multiple branches in it, so check it out. There are some more examples in that project, especially the different ways to create an instance of the embedded storage manager and so on. There is one question. Is it relevant only for the local file system, or is it relevant if you use Reds or PostgreSQL as a storage option? It's also relevant for different storage systems, because the size of the binary blobs. So on the file system, it's just a file, but on your PostgreSQL database, it will be one blob, which is sized 8 megabytes, for example. And it's the same on your PostgreSQL, or even on your AWS S3 bucket. You should take care about that. If you don't care about storage, then leave it as it is. So, but it makes sense. So you have to adjust this, especially when you use an increasing amount of writing requests. Then you should adjust this in a high frequent way, I would say. Yeah, it makes sense to. You should just check it. If it works great for you, keep it as it is. But with, as I said, with an increasing amount of concurrent user, it could be the case that you have to adjust this a little bit. Okay, you just have to know there are possibilities to do that. In most of the cases, you can keep it as it is and live with it. It's totally fine. Okay, so on the last part, I would say, the last important part, I would say, is let's skip the customizing and the REST interface a little bit. We can do this at the end if you are interested in. But I just want to jump into the cluster and talk a little bit about replication and what's going on EclipseStore MicroStream cluster and so on. I think that's quite interesting, and therefore it's part of the advanced training, and that brings me to a small presentation, and just want to give you an idea of what's going on, what's coming up next, and what you can do. Okay, let's talk about Cloud Cluster, and let's talk about a little about different architectures and the pros and cons. Let's start at the monolithic application. In the last 5 years, I would say on most of the conferences, you always hear that word. You have to use microservices and do microservices, and microservices are the most powerful thing, and it's totally okay to use it, and you have to do it, and stuff like that. I would say there is no definition of a microservice at all. So there is no definition how big a microservice should be. There is no definition what exactly is a microservice. So, and that's an important point. There is a use case for sure for microservices, and especially when you have, for example, 500 developers for one project, you have to find a way to split up the project, and that's one way to do this, creating microservices that enables the team to work on its own service and to make it happen. But most of you have monolithic applications, and you are good to have this. They working great for a lot of people nowadays, and it makes sense to split up sometimes the monolithic application into some good-sized modules, I would say. Let's say you have 3 developers, then it could make sense to split it up in three different modules. That makes sense, but it doesn't have to be micro all the time. So do it and think about what could make sense to create some modules. But yeah, that brings me to the point. Monolithic applications are really great, are working great. They are easy to deploy. There is no specific infrastructure needed. And yeah, I would say most people are able to maintain, and it's an easy technical vertical scaling. And vertical scaling is also quite interesting when we talk about MicroStream. And most of the time, we are using relational databases, and by design, I would say they are quite slow because data are segmented into different parts to keep it small. This is not necessary anymore. Why to split up data? We have enough RAM and we have enough bandwidth to transfer the data. Sorry, I forgot what I want to say. Vertical scaling. Yeah, and it's sometimes, especially with MicroStream, it is great to just scale vertically because MicroStream is that much faster. Then you won't need. So, for example, on a process where you need with a PostgreSQL, you need 78 or 80% of the CPU. On the MicroStream side, you will only have 2% or 2% of the CPU usage, for example. That means MicroStream scales that great that vertical scaling is totally okay. Some people ask me, what about data scaling? How to scale the data when it grows more and more? The point is, on some products that makes sense to caring about that, but in some other products, the question is why not to move data to archive, for example. So I knew a lot of projects, they're processing data, for example, within the database of the last 30 years. So why to have that? Why not to move data after 2 years to an archive and just operating on the last 2 years of data? That makes sense. And that brings you to the point where data isn't scaling anymore because it stays all the time at the last 2 years. There is a service at night, it runs every night, which decides, okay, this is data, this is longer than 2 years, I move that to the archive. And this is the point where data is no scaling anymore. It stays always the same. And then we only have the problem how to scale for concurrent user. That could happen every time, but it's a different use case. So, but just to summarize that, monolithic applications working great. There is a way to vertical scaling also with EclipseStore or MicroStream that works really great. Just try it out and you're good to go. But there is always one point where you want to have a cluster or multiple application. There is no horizontal scaling. Of course, we are not able to create another application and another pod and another one because the data itself is a stateful application. Each application server has its own database, and it's kind of like a state. And if we start a second one, it is not possible because the database is totally different. It's empty, for example. Yeah, so it's not a stateless application anymore. So, and therefore it's not fail-safe. What does fail-safe mean in your? What do you think? What is fail-safe? Any idea? No one. Okay, fail-safe means to keep the or how to say it in English. That's not the easiest part of that. To decrease the result of a fail, I would say. So it's not to prevent from failing. This is not what fail-safe means, but it is to decrease the let's call it result of some errors or some stuff like that. Next point is high availability. That's fail-safe is not reducing the risk of failure. That's for sure one point, but it's more to at the end, what happened if an error occurs, to keep the I couldn't find the right word for that, to keep the result as, or the result as decreasing. So I think that's the main purpose. reduce the impact. Yeah, thank you. That's the right word. Thank you. Okay. High availability. What means high availability? It's the with an increasing amount of concurrent users or with an increasing amount of concurrent accesses to your application, keeping the same or keeping the response times at the same level. That means high availability. And these are the 2 points which are very important. And if you need some of that, then we have to scale. So, and then we have to talk about replication. What about this architecture? So we have on the right side, we have one, yeah, it's a data provider, could also be a database, doesn't matter, whatever else. So in that specific case, it's a REST provider. It provides the data via REST. We have EclipseStore in it, and there's a Java virtual machine in it. And on the second level, there is, yeah, let's call it an application server with some business logic. We have RAM, JVM, and so on. Could be Spring, Micronaut, Helidon, and we have a UI so a quite 3-tier architecture, I would say. Is that a monolithic application? Maybe yes, maybe not. But this is also working great for most of us. It's the same. But to be honest, it's more advanced deployment, of course, and a lot of technology in that stack. So you have to know a lot of different things within here. And it's still not fail-safe on layer 3. And it's also not high availability on layer 3 because this layer is stateless. It is. This one could be stateless, but layer 3 has a state, and it's not made for replication. So we are not able to create again and again another pod. But let's see how we could solve this. We could find one solution would be a queue, right? So we could create a queue in between these 2 layers just to improve the communication. So that means within the queue, the data can stay, or the read and write request can stay within the queue as long as the last layer restarts, for example. That provides us fail-safe, right? We have to wait a little bit longer for the data, of course, but it works basically. But there is still no high availability because with an increasing amount of requests, we have an increasing amount of response time, right? So that's what high availability means. This could be the next situation to say, okay, there is one load balancer, and it divides the read and writes to the different nodes we have here. And this solution, we call it replication in a way, provides all of the advantages that we need, especially fail-safe, high availability, load reduction, and efficiency. So that's okay, but it's highly complex. It's always the risk of data loss, especially when you use technologies like Redis or, for example, MongoDB and stuff like that. They have all mechanisms. They said, okay, basically we are able to do replication, but this is an eventual consistency. You might lose data, for example. It's always important to carry this. So you need multiple servers, and of course it's not doable for most of us, and it doesn't have to, because in my opinion there are only a handful of companies that need replication like this. Yeah, because most of them are using replication just because it's part of a product. For example, Redis, they use Redis as a cache in between the database and the application itself, and Redis comes with replication. But yeah, it's just a technology to increase the performance of the slow database, I would say, and that doesn't make sense to me. let's talk about that replication and why it is so complicated and what decisions has to be made. The first thing is it async or is it synchronous? And the explanation what it is writes are blocking or writes are non-blocking or writes are blocking. I think we all know what does that mean, but you have to make a decision. What is your preferred way to have that, to have the replication? Is it a single leader architecture, multi-leader, or no leader architecture? There is, as far as I know, there is only one technology or two. Yeah, there might be some more, but I didn't know it. So there are two products on the market. They have a no leader architecture. This is, I guess DynamoDB is one of that, and not sure if there is another one. Redis, I think Redis is a multi-leader, I guess, but not sure about it. The only thing I know is a no leader is DynamoDB, for example, from AWS. But there are issues on that. When we talk about the MicroStream cluster, it's a single leader architecture. There is one writer node and multiple reader nodes. That's also interesting. Strong consistency or eventual consistency. That's also up to your project itself, or it depends on your needs. Is it okay for you to lose data on in some situations? That could be the case. It depends on, so for example, the DynamoDB is eventually consistent, that it's possible to lose data. It's eventually consistent because of its no leader architecture. What infrastructure do you need? Kubernetes and so on. Or am I able to maintain such a system? That's all questions you have to do. And therefore, we decided to create a system which is a platform as a service, I would say. And that hides you from all the different problems we have on that system. And that brings me to the MicroStream Cloud Cluster. And what it should be a central point for hosting your applications. No matter if you want to use replication, you will be able to host your data provider applications with MicroStream or EclipseStore. And that, as I said, a simple application hosting, cluster hosting and configuration and data replication within the cluster. That is what the cluster provides. And hiding you from the complexity of infrastructure, dealing with security, dealing with Helm, and dealing with Kubernetes and stuff like that. That is the idea of MicroStream. And of course, provide you monitoring, logging, backup out of the box as a fully managed Kubernetes configuration. And in some parts, it's kind of like, I don't know if you ever heard of OpenShift. It's kind of like an OpenShift, especially for data storage with MicroStream, and it provides you a full functional Kubernetes cluster, but it's fully managed, and you will be able to deploy your application in it, and replication is doing out of the box and stuff like that. How does the cluster works? The first question is, how could this work with EclipseStore? Because it's a framework. How to enable a framework to work within a cluster? And the answer is standardization. And the idea is, okay, let's think about when we use Micronaut or Helidon or Spring as an application base. Then all these three frameworks are quite standardized, nothing special in it. We use EclipseStore. That's what we made, so we take care about to keep it working within the cluster. EclipseStore as a technology and MicroStream as the cluster for the cluster API, and REST. REST is also quite standardized, nothing special in it. It's working great. And then we have in the middle your business logic, which contains of streams and REST implementations, merge login and merge logic and stuff like that. And at the end, you will get one project which can be deployed, and with some some special parts within that application, you will be able to cluster it out of the box. So just you give it to the cluster, and our API is able to replicate your application and do all the merge and replication stuff of the data in the background. Let's have a look at that. There is one project within my. I'm not sure if this is a public one, but let me just check. Yeah, it is. It is public. It is. JSON cluster deal. There are multiple ones on my GitHub account. So here we are. That's the project. It is called MicroStream Cluster Demo. And as you see, it's a straightforward micronaut application, which consists of all the stuff we already talked about. We have controller classes, we have a storage, but this is different. So there is no longer an embedded storage manager. So instead of an embedded, we're using a cluster storage manager, and that's different. And that enables you to replicate the data. There is a mechanism in the background which replicates the data via a Kafka cluster. We will have a look at that later on. And the point is, or the interesting part is, as you see here, you will be able to change it directly to embedded storage manager to test it during development. And when it comes to deploy it, you can upgrade it to the cluster storage manager. The API stays the same. There are some parts of the application which you have to change, but only some smaller parts. And that's it. And then it enables you to provide us that project. And let me just show you how it basically works at the end. So this is the UI front end of the platform, and you are able to download a specific version of the base project. So at the moment you will be able to decide should it be a Micronaut project or a Helidon one. In the future, there will be another one, a Spring solution, so that enables us to replicate Spring applications also. And you could choose the base package, the project name, the Java version you want to have. And this provides you kind of like a template with all the things you need for the cluster, I would say. And let's say we already created the application, then we could move on. There is one cluster which is created for the GeekCon few weeks ago. I decided to keep that, but you will be able to add a new cluster. You will be able to decide what cluster provider it should be, an AWS, Google Cloud, Azure, and so on. You will be able to decide what region it should be, and then you will be able to choose the size of your application. It depends on how many millicores and RAM you need and so on. And you see there are only smaller parts because it's beta at the moment, and we are working on a little more extended version for the moment, and that will change a little bit. Therefore, we stopped to increase the pods. But yeah, I think in 1 or 2 weeks, when the newest version is available, you will get the possibility to create bigger applications. There is auto scaling, so that means you will be able to decide which is let's say we use, for example, this one, the small solution. There are 2 replicas, so two replicated pods with a load balancer, and then you can decide the min cluster size is 1 and the maximum cluster size should be 2. There is something which is not working correctly, but that is basically how it works. Then you can provide us the application. You can you can create a cluster name, the application type, Micronaut or Helidon, and then you will be able to provide the project via JIT. or via jar file. That's up to you. Then we are able to make some adjustments to the storage backup side. So how often you want to do backups of your storage. The authentication is important, and you will be able to create a VPC, so a virtual private connection to your AWS account, for example. And there are some proxy settings, and I think that's are the most important ones. As I said, it's a single leader architecture. That means every write request should go to one specific node, and this is the way how to make the decision what request is a writing request and which one is a reading one. And there are 3 different types to separate those requests. The first one is by the HTTP method. So put, post, delete, patch will go directly to the write, to the writer node. And there is another one to use the URL path or to use some specific header values. That means that every request which contains the header value will directly goes to the writer. But this is the default, and that's it. Then you will be able to have the cluster like this. And it provides you all the things you need. So all the different stuff you want to see, CPU usage, RAM usage of your nodes, and you will be able to adjust all that stuff from before. So, and you can see the backups, for example. You will be able to download the backups. You could monitoring your nodes. You see the CPU usage and stuff like that. There is logging is in place. That means you could check all the log entries of your nodes and your infrastructure. And there is an uptime configuration. Not sure if the uptime configuration is still in place on the newer version, but we are working on that. You are able to decide, okay, my cluster should run from Monday to Friday, for example, to save costs, of course. That's up to you. That's a great feature. And yeah, and at the end, we are able to access it. This is the URL. So not sure what project is deployed, but we can try to access it via browser. Let me just try it out to check the GitHub. I'm not sure if it is this one, or there should be one which returns all the products. Yeah, here it is. So so I called the URL of the cluster, and you see this is the data which is returned by the cluster. And that's how it basically works. So that means you create your project. You will be able to create multiple, call it microservices or micro data provider or whatever else. It's in a way kind of like create your own database, I would say. And then you will be able to deliver that to us. We do the replication for you in our platform, and that's it. So this is how it basically works. There is a lot more explanation to that. It's just to show you what comes up in the future. And there are always the question, how it is, can I use this on-premise also? There is, we are working on on-premise solution. It looks like the same solution that we provide as a platform, and then it's a product. You will be able to deploy this to your Kubernetes on-premise server, for example, and then you could do this on your side as an on-premise replication service for your company. So this is an upcoming product. In the next time, it will be available. I don't know when, but yeah, it will be available soon, I guess. Okay. So that's the part for the clustering and the replication. Any questions from your side? I'm a little bit afraid you fell asleep, so because it's late and maybe the topic is boring, but I hope you are still there. Okay, let me just see. Okay, no questions so far. So then I would go on with the very last topic for today.
Christian, I have a question. It's not related to the cluster.
Okay.
But I was, in context of this, I was thinking about, I don't know if it makes sense, but to have multiple routes. So like if you have like, yeah, I know this is a rare case, but maybe you have an application connected to the two databases.
Yeah.
And yeah, is this something?
Yeah, that's an interesting point. Multiple routes, that makes sense. It's an idea of I always explain that when it becomes so many people talking about scaling data and stuff like that, and the idea is to create multiple data provider for one huge database. So that means let's say split up your database into specific parts like all customers, all orders, or stuff like that, and create multiple data provider for each module. I would say that gives you an incredible amount of advantages because when let's say when your order service goes down, all the other services are still in place and still working and delivers data to your application. That makes totally sense, and it makes it so much more easier to scale when you have only smaller parts of your application. And this is exactly what you can host also on the cluster side. So also you will be able to host those different. There is also a more extended way. An idea to split up the database and deploy it to AWS Lambda. Not sure if you know what Lambdas do, but that's also possible. There is one project within my GitHub account that enables you to deploy this to a Lambda, and then you have a small mechanism to keep the one Lambda
alive.
Not alive, but there is a state in between. There is Lambda is off and Lambda is used, and there is a state in between which is called, it's not sure, it's a hot, we call it hot state, and that means that the Lambda is still in place, but it's free, it costs nothing, and it needs about 1 or 2 minutes where the Lambda stays in that hot state. And if you just make small calls, small or lightweight calls to the Lambda, it forces the Lambda to stay in that hot case all the time. And this is great because you will be able to deploy your database to Lambdas, and it costs you barely nothing to have that database. It's just an idea to use that in that way, but it could be quite interesting. And even AWS gives you the possibility to keep it in that hot state, but it's it's quite expensive to do that. And with that small trick, that's by the way a trick which is recommended also by AWS. They have an own article for that. It makes sense to do it this way. Yeah, it's quite fun.
Nice. So if you basically I would have multiple storage managers.
Yeah, it's also possible. Yeah, you could have.
So I can have multiple routes, and I can have multiple storage managers, of course. But I cannot have multiple routes. Just one route per storage manager, huh? Right.
Yeah, it's not possible to have multiple routes, and to be honest,
that doesn't make sense. You can just use storage manager.
Yeah. Storage manager. That's no problem.
It's like maybe you can compare it to, I don't know, like in I don't know if MySQL has this, but Postgres has like schemas.
Ah, I see. Yeah. Ooh. Yeah, it works in a way. So we use this especially when we want to have some different clients of um, of a database, I would say. Then we use, for example, when we have a book selling company, then we have one root, and this root object should be the company. Okay, that's okay. But what if you have multiple companies? Then we use a list of companies which contains the books and so on. And this is where the database becomes multiple clients, I would say. One company is one client, and each client is part of the collection.
Multi-tenancy, yeah.
Yeah, that's right. Thank you. That's what I missed, that word, multi-tenancy, yes. A lot of different possibilities. There is also one recommendation I've seen last week. It's the first time I've seen that. Not sure if that is a great solution. Give me just a second to find that. Dictation storage. I think it's part of the lazy of the storing data, lazy and eager storing. Timestamp, lazy clearance. Something with meeting data, storing. I couldn't find that. There is one example in our documentation, which so the point is that sometimes it makes sense to have only to have multiple storage manager, but only one data structure. So then you have to find a solution how to know which object belongs to what storage manager. That's the point. And there is one recommendation to do that, to use the storage manager as a transient field within your objects. I think that's one way to handle that. But it enables you to have only one data structure for multiple storage managers. And especially on the question having multiple storage managers, I think this project could be a good example, because this is one which has multiples in it. In the DB class, you see that here there are multiple storage managers. And each storage manager is initialized in a different way. It's just a small example to see what different ways we have to initialize the storage manager. This is the one we use often, so the builder pattern. But that is the XML one, and there is another one which is based on the foundation solution. I think that's the most complex one, but sometimes you will need that in this way, because to adjust the more deeper things. There is one example I created a few days ago. As I said, to use the storage on the hard disk on a persistent volume, but writing the mirror to an AWS S3 bucket, for example. Then for that solution, you will need the foundation way to initialize that.
Okay, yeah. And there comes another question in mind. So maybe we use that for archiving too, or what would be the best practice to use archived data? Because you mentioned
archived data.
Yeah. Or to store and read.
Yeah. Okay. I would say archived data is, I would store it in the lazy way. So that means the data stays on the hard disk because it's not needed in the RAM.
Yeah.
You have to find a solution if someone accesses the data once a month, for example. So when you
history in I don't know,
Yes.
if you get your retirement in Germany.
Yeah.
And then
of course. Yeah, that works with the lazy solution. That will be okay. In my opinion, it's also okay to use the already existing relational database as an archive. That's okay to use high-speed data via MicroStream and or EclipseStore and use a smaller Hibernate implementation in the same project just to archive the data to a relational database. For that, a relational database is totally okay. Yeah, could be. I think there are tons of different solutions which can be used with EclipseStore and MicroStream. It's up to you to use it in a specific way. There's some people ask always what are the most use cases of MicroStream. Use it for everything, as a database, as a mock-up database, microservices. There are so many different use cases. It depends on you and your project and your needs. I think that's the point.
Yeah.
One question: is it possible to use different storage managers to have different backends, like store something in JSON or in XML?
So the result will always be the same. It's a binary format. It's a non-readable binary format. If you want to store a JSON file directly or as it is, then you will need a kind of like a binary file format, I would say. I'm not sure if that answers your question, but a storage manager or the MicroStream storage manager always creates the same binary format. There is no way to create a readable JSON format, for example. That's not possible. Therefore, you have to create a REST endpoint which creates you the JSON, for example, as an export, for example. But hopefully that answers the question.
Yes, thank you.
But byte array would be the solution for large objects, or
yeah, of course,
yeah.
Of course. So there is one, and especially in the lazy, there is one example I provide in the advanced 1 training. Just switch to the right branch. Change to lazy, multiple maps, lazy could have changed to lazy. Let's double check this. This is a lazy list of persons. 1 second. There is one example within the presentation here. Okay. Yeah, this one. This is yeah, I would recommend to do it like this. So there is a lazy, and this is the byte array. This is the JSON part, which is within the byte array, and sometimes you need something you want to search for, kind of like an index or stuff like that. Then I would recommend to do it this way. It's the same using images and blobs all over, I would say. That means you have the string stays in memory to search for, and when you call the get method on the key side, you will get the JSON file. That will work.
It's quite the same like you have in JPA or something like that. You have to map to a Java object, or you choose your data type. What you would choose in JPA as the mapping type for your entity.
Yes. No. Okay. So, but there is no mapping.
Yeah, there's no mapping. Yeah,
anymore. But
but the question for what you use for a data type would be like the same what you would use in your JPA entity.
Yeah, maybe not, because now when we talk about this, especially for a JSON file, I wouldn't choose a byte array. I would choose a string for a
string.
JSON.
Yeah, right.
A string would be a better solution than a byte array, in my opinion.
But for your JPA entity, you would choose a string too, to map.
Yeah, of course.
But this concept is meant to avoid larger amounts of data inside RAM, and normally you would do that if you use a kind of adapter pattern. You could serialize image data to the temp directory, and if you have to move the object from one point to another, you can read in the image data, and so to prevent it to blow up the heap.
And that makes really sense, because we in the past we had some projects where we consume large external REST endpoints, and they deliver us tons of data with thousands of it's with big trees within the JSON file. And at the beginning, we tried to parse this to an object structure and try to store it that way, but that increases the amount of RAM enormous. Then we thought, okay, we don't need all the data, so let's keep it in the JSON way as a string format and store it lazy, and just map it at the moment we need to get into it. So that makes more sense. So that means sometimes it makes sense to store data in a JSON way, just to save storage or RAM on the application side. Yeah. Because sometimes it's quite an overhead to have objects and stuff like that, because every object needs reference and sometimes it's better to have just a string within the RAM. Then we have the same structure like this, and we just put the indexing stuff within the string to search for the right data. Okay, and there are a lot of more, especially when it becomes to data mapping. We already talked about this a little bit. There are custom type handlers, for example. So this could be interesting when you want to store third-party types, and sometimes it makes sense to have that, but it's quite dangerous to do that, because whenever a third-party type changes, for example, they move the class from one package to another, MicroStream always references the types via the full qualified name or the package name, and that leads to an issue at the end. You have to change that. So we could have a short look to an example. Here is the database, and this is the persistent type dictionary. This is where the object keys and the type IDs are collected. And you see here, for example, this is the author object, and it consists of type ID, and this is the class path of the author. And that's what I said. If you use third-party objects and something happened and they're doing refactoring or stuff like that, this will lead to an issue within your application, and you have to change this at the end. But I would not recommend to use third-party objects within your storage, even if it is working. But and therefore we provide kind of like which is called custom type handler. And there is one example of a custom type handler, especially for a time slot class. So there is, every time we have an instant here, and let me just check what has happened at the so you see that here, that is a binary type handler for that specific type, and it changes the way that the data type is handled within MicroStream. And that is kind of like a mapping, I would say, but especially for that to decrease the amount of references within your storage, because it creates a long field out of that instant data type. Just because that instant data type consists of a lot of different fields in the background, and it could make sense to keep it more simple, just a long value. That's most of the cases totally enough to store this, and it's quite more cheaper to have a long value instead of an instant. And this could be also a solution for third-party objects or for any other objects which are needed within the storage. Specific type handler. It's a very special thing, but it's possible. And there are some more functionalities like this. As you see, we have a custom legacy type mapper. To be honest, I never used this before, but it's there. It could be used. It's part of our documentation. We have custom storing behavior. So that means you will be able to define different storing behavior on a specific object, for example, and even for a specific field of that object. So it could be that some fields are stored lazy and some others are storing eager. You will be able to adjust this. But yeah, that is really deep stuff, and you will not use this all the time. So custom type handler makes sense. And also there is another one, which is sometimes important. It's the custom class loader, for example, especially when you use Spring as an application base. You have to set the class loader, because Spring uses a different class loader than MicroStream. So you have to adjust this, especially on Spring application. But there is an example within our documentation. Let me just check that. Yeah, it looks like this. So, and this is also a point where you have to use the foundation way to initialize the storage manager to set different class loaders to different types of your application. And as far as I know, so one big example is Spring. It uses different class loaders, and yeah, some others, but sometimes it could be quite helpful to know that.
Probably okay. If you use MicroStream inside an OSGI application, it would be also needed to have a own class loading.
Ooh, that's a good question.
Because if you have a bundle class loader, it's completely isolated.
That could be right. Yes. Just try it out. So if you get some weird error messages and MicroStream is not able to find the right type, you will see that on the exception. So you will get a weird exception, which is called, he tries to map a specific type to another specific type, but it's the same. Then you know, okay, there is something within the class loader which is not working as expected, and then you have to set it. Yes. So he tries so he says in the exception, okay, there is a class like this, and they both are equals, but there is an error message or an exception, and then you know, okay, something went wrong with the class loader.
So probably the classes are loaded from different jar files, and then
yeah, that's right. So then it makes sense to separate that. But as I said, there are some examples on GitHub to see how it works, especially on that Spring application. That is not a big deal to do that. Okay, so there are some more minutes left, but I would say it's all from my side. We did all the core topics for today. If you have some more questions, feel free to ask. I'm still here, and I am doing my best to answer it. So let me just check.
I have a question concerning migrating data models.
Mm-hmm.
I think you said it in advanced 1 training.
Yeah.
So that it's on your own. But is there anything planned in the future for example, to just to make it easier if you have on-demand instances of your application at customer side, and one has version 10 and the other has version 15, and I have a migration path, so it would be a little bit not so comfortable to just deploy the 5 versions in between. Every version had a data model change.
That's so I would basically recommend to do this via your version control system. You can do this within Git and create tags and stuff like that. Maybe
of course, yeah.
That would help to keep it versioned. So
the point is just to skip versions, or not to skip, but to include multiple evolution.
That's never easy. I mean,
it's always
take GitLab. If you have a GitLab installation and you want to go from one major version to another major version, there are several
changes,
steps in between you have to take to able to convert your GitLab installation from one version to another. And if you skip versions, well, you have to test these migration paths, and this is a lot of work. And if you have a software vendor, you have to test it and you have to provide this information to your clients. And I would probably say, let's externalize the whole object tree to JSON or to a different format. Then read it in a higher version and try to match the JSON towards the actual data model.
Got it. So
that's fine.
Give me just a second. There is maybe you have to check the legacy type mapping here, and I think I explained it there is an explicit mapping. So there is a way to define your changes within those mapping files here. They look like this. And this describes the way from one data structure to another. But I think the point on that is that sometimes it is needed to migrate the data from one version to another. And that is not covered in that specific case. So this handles all the easy way stuff, I would say. But if there is some bigger changes where some migration is needed, then this could be difficult.
Sorry for the question. I'm a big fan of Liquibase. Also in the past, when it's also when you have in the past, I had a very, very big monolithic application where like 200 developers developed on. It was just not. It's just okay. Maybe you write it by your own at this point, but it's very, very comfortable to just use Liquibase. So if you are not in if you're not like Atlassian or something like that, if you have like you said, you have a monolithic application or a monolithic application, and maybe you have like 50 customers or 200 customers that use that and not 1 million. It's very convenient that you have a low level that you need to maintain the application at all customers, because the most thing is always the database migration. Where you change your types and stuff like that, or you have some default data you put in, and it's just very comfortable with Liquibase that you can say, okay, I had this version at this point, and this is the path from migrating my database from version 1 to 10. And no matter which installation you have, you just deploy it, and Liquibase knows, okay, I am version 1. I need to do these steps to get to version 10.
Yeah, yeah. So I would say for the moment, the only answer I have is you have to do it by yourself. So that's the only answer I can give. But there is that the interesting would be just bring it as a GitHub discussion topic, and that forces us to think about that topic. And maybe there are some colleagues they already use it in a specific way, and maybe they can give you a hint, or it leads to a new feature of, let's say MicroStream or EclipseStore 2 or 3. Just write it down to GitHub discussions. That would help. It forces us to talk about this topic.
This would be, I think I will do then, because it's just one database. You're on your own. You're not like Liquibase, like having 15 database management systems.
Of course,
and Liquibase is as simple as having 2 tables, and just looking what is already done or not.
But maybe there could be a class which consists of the history or stuff like that. Maybe there are some solutions, or maybe there are still some best practices on the market or within our project on different colleagues. Please put it to GitHub discussions, and let's try if we could find something that helps.
But even if you use Flyway or Liquibase, you write your own migrations inside these tools, and
that's right. You have to
do the same on the object level then. So you have to maybe have a kind of a version attribute and have inside your software somehow a plan how to migrate from one version to another, basically making that what Liquibase or Flyway provides.
Just any file that defines what to do.
So
but that's a missing feature on POJO level.
right. This is right.
That's true. Makes sense to think about that. I see the point. So especially when you have to move from different major storages to if you want to have multiple changes at once, that could be an issue, because we always say, okay, do one step after another, but sometimes this is not possible. You have to, and now at the moment you have to start up, change the version, start up again, and step by step you migrate the version to do you migrate the storage to the newest version. But it must be a way to do it from, let's say, to jump from version 1 to version 2, and to do all the migration stuff at once. That makes sense to have a solution for that. Otherwise, you have to do the changes step by step, and that's not possible for users or for customers.
Well, you could use different packages for each version, and the newer version knows the older version, and you can kind of have a copy constructor, and you pass the old object to the new object, transforming it from one to another, and then inside the copy constructor you know exactly what you have to do.
Could also be a solution. But it's not the easiest thing. That's right. It makes sense to think about that. Okay, some more stuff. So then I would recommend the JCon next week. And especially we announce some newer features and new collection types and indexing stuff and so on. It could be quite interesting, especially for EclipseStore. So it's, as far as I know, there is a ticket code, so it's free. So yeah, shouldn't be a problem to be there. I would say from my side, that's all from my side.
Christian, can you on the JCon, can you recommend any session from MicroStream that has something that was not covered from you in these free workshops? Yeah.
Yes, especially the newer feature like the index API, the big table stuff, the giga table stuff. This is all stuff which is upcoming. Not. Let me just double check. There is the. That needs a little bit, but you will see that on Thursday there is a program which is already available, and I think there are most of the topics on Thursday. There are some indexing stuff and the giga table release and stuff like that. Upcoming new features of EclipseStore and MicroStream. I think that's most interesting, and most of the other stuff is covered by the training. Yeah, but there are some new stuff which could be interesting.
Okay, thank you.
If I might ask the one last question. I asked the question in the chat 35 minutes ago, but it didn't manage to be answered. Okay. Is there a way to send you these questions on some email and get an answer about that?
Of course. Yeah, let me just share my email account. Just send me your question, and I will do it.
It's the one from 2025 IT Ivan Tanaskovic. Can we use storage REST service Jersey as external universal external CRUD API, for example, from another application? And another one is obviously we can define in configuration of storage provider. We can define backup directory if we are using local storage manager and using local file system. Can we do the same with Redis? For example, 2 instances of Redis. One is for storage, another one is for backup.
Got it. From the technical perspective, it would work, but I would not recommend to do that, because the REST service Jersey, it's just designed to use it on the development side. So it's just a developer tool, and there is no security in it, and I would not recommend to use this in production. So that's, I think,
can we utilize if we embed it inside the Spring Boot 3 application? Can we utilize Spring Security as security layer for it?
So instead of using the REST client, I would just use the REST features of the Spring application itself, or if I get it right. So I think that especially that EclipseStore REST service Jersey is not made for using it in production. It's just a developer tool, just to activate it and to see the data during the development process, because many people are always asking for a data backend. I mean, we want to see the data and so on. And this was exactly made for that, for them to see the data.
And what about Redis backup, like main Redis and Redis for backup?
Yeah, that would work for sure. I think it's the same, like working on hard disk, but creating a backup on AWS S3 or Redis. This is totally up to you. You can do this. Yeah. I don't know if it makes sense to have the storage in Redis or to have the storage in AWS S3. Yeah, could make sense, but you have to think about that when you want to access lazy data, it needs more time to load it because all the data has to be transferred to your application instead of having it on your hard disk. That's the only difference. But when most of the time you use on in-memory parts, then it makes no difference. Of course, the store data needs a little bit longer, but that's it. That's the only difference between that.
But for example, if I want to have a backup in different AWS zone, use it, for example, in one zone and have a backup in another zone in case of, I don't know, failure of entire AWS infrastructure for particular
that is totally
zone.
on you, I would say. To create so I think the question is what kind of backup do we talk about? Is it the full backup? Then
a full backup as we did in configurations for the local file system.
Okay, but it's not the mirroring, right? So for the mirroring, it's only one specific target, storage target is possible. So for the mirror, but the full backup, you can do whatever you want with the full backup, and this enables you also to write the backup to different regions, for example. That will be possible. Another point, or that's also interesting, it's not possible to access the backup itself. So that will lead to a crash of the database, because the point is there is no read-only mode on MicroStream. That means whenever you access a storage, the housekeeping process and also the garbage collection in the back end starts to work on that storage. And for example, when you access the mirror at the same time as another application writes something to the mirror, your application will crash. That is not possible.
But so, if it's exclusive for a single monolith,
yes, it is. It is. And
if it's, then it wouldn't object in any way. The backup is like normal backup.
Yeah.
It's not another channel for I don't know, speeding things up. It's just backup and nothing else. Yeah. And in case of failing monolith in one zone, if we detect that failure, we can start another instance with backup of that data in another.
Yeah.
Okay, thank you.
Yeah. Exactly. So this is how it works at the moment on Allianz Insurance Company disaster recovery. We prepare two different applications, and we do a storage replication to another region. And in case of disaster, we switch the region and use the application on the other region. So with a little bit older storage, I would say. So,
is it when you say replication? Is it normal backup as you demonstrated in configuration part of this tutorial, or is it some special Java code that is handling the replication of the data between the zones?
No,
can we use for?
So we do the replication on AWS. So we use the replication, but we backupping the data to AWS and S3, and S3 replicates the data then to another region.
And one last question. Now you mentioned the replication. Is there some mechanism like Debezium that will emit all the events that happen, like deleting, updating the graphs in EclipseStore that we can use? Is there something similar to Debezium for EclipseStore? If you know what I'm referring to.
Not sure. Can you repeat that a little bit? So
Debezium, it's a solution. You attach Debezium to Oracle or PostgreSQL. Okay. It reads the logs of the database and emits events to Kafka if something has been created, updated, deleted, etc.
Okay, got it. Yeah. Okay. The question.
I'll write the name in the chat.
Yeah.
Sorry, wrong.
Okay.
Never
heard of
it. DB-server.
Okay. And it's kind of like a.
It's a good mechanism to replicate different databases.
I see. It's it could be used to replicate. Yeah. Got it. I have to check this, but yeah, it's kind of like the mirroring functionality what we provide a little bit. But maybe that could also be done by yourself within your code. So whenever you store the data, and I think our replication feature would cover this. So you know the replication which is used at the moment within our cluster, it does the same way. It writes the data to Kafka, but you're not allowed to use this without our cluster solution. But in the next few weeks, we will release the version, and then you will be able to license this solution. That could help, I guess. It's not done so far, but we are working on that to provide it.
So it's only for the cluster.
Yeah. So this is a functionality we already provide within the cluster because we're doing data replication on the cluster, but it's not available for now to do it within the framework. There is no way to do this within the framework, and I think that's the point. And we are planning to release a more extended version, so which contains that data replication, and then that enables you to do your own replication of the data to Kafka, for example.
So there is no general change data capture mechanism available in EclipseStore as it is.
Yes, that's right.
Okay, thank you.
Stream changes, but that's a good tip from your side, or a good advice. So I will check this. That sounds interesting. Maybe that's also a thing what could fit to GitHub discussions. If you have any ideas for improvements or stuff like that, that's why EclipseStore is an open source project. So check it out, what's possible, and make some suggestions. It's totally up to you to create a quite good project at the end.
Okay, thank you. I will.
So I promised you to share my email address, microstream.1. So if there are any further questions from your side, feel free to ask me, and I will do my best to answer that. Okay.
Thank you, Christian. Thank you.
So let me also say thank you. I hope it was interesting for you and not that boring. Yeah, I wish you great success with MicroStream. Hopefully we see see us on any, let's say, conferences or stuff like that. That's all from my side.
Definitely.
Have a nice evening. Thank you. Bye-bye.
You too. Thank you.
Yeah,
Goodbye,
bye-bye.